Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is Alkyl and Aryl Halides, SN1 and SN2 reaction mechanism. Today, we will talk about the SN1 and SN2 reaction mechanisms of alkyl and aryl halides. This topic is a crucial part of organic chemistry and is very important for exams like NEET and JEE. Let's begin without any delay. First, let's understand what alkyl and aryl halides are. When a halogen atom such as fluorine, chlorine, bromine, or iodine is attached to an alkane or benzene ring, we get an alkyl or aryl halide. Alkyl halides are compounds where the halogen is attached to an sp3 hybridized carbon, whereas aryl halides have the halogen directly attached to a benzene ring. These compounds undergo nucleophilic substitution reactions, which occur in two ways, SN1 and SN2. Now, let's talk about the SN1 reaction mechanism. SN1 stands for Unimolecular Nucleophilic Substitution. This is a stepwise reaction that occurs in two stages. The first step is the rate-determining step, where the leaving group departs, forming a carbocation intermediate. A carbocation is a highly reactive species that is ready for nucleophilic attack in the second step. This reaction mostly occurs with tertiary alkyl halides because their carbocations are more stable due to resonance or inductive effects. SN1 reactions generally take place in polar protic solvents such as water and alcohols, which help stabilize the carbocation. In this reaction, racemization occurs, meaning that when a chiral center is present, both enantiomers are formed. Now, let's understand the SN2 reaction mechanism. SN2 stands for Bimolecular Nucleophilic Substitution. This is a concerted mechanism, meaning the reaction is completed in a single step. In this reaction, the nucleophile attacks from the back, while the leaving group simultaneously departs. This results in an inversion of configuration, known as Waldane inversion. SN2 mechanisms mostly occur with primary alkyl halides because steric hindrance is minimal. If steric hindrance is high, as in tertiary alkyl halides, SN2 reactions become difficult. SN2 reactions work best in polar aprotic solvents such as acetone, DMSO, and DMF, as these solvents keep the nucleophile free, allowing it to attack efficiently. The reaction speed or rate of these two mechanisms depends on different factors. The rate of SN1 reactions depends only on the concentration of the alkyl halide because the first step is slow and rate determining. Therefore, SN1 reactions follow first-order kinetics. In contrast, the rate of SN2 reactions depends on the concentrations of both the alkyl halide and the nucleophile, making it a second-order reaction. Another important difference is in stereochemistry. In SN1 reactions, racemization occurs, meaning that if a chiral carbon is present, a mixture of both enantiomers is formed. This means that if an optical isomer is used as a reactant, the final product will be a racemic mixture. On the other hand, SN2 reactions result in complete inversion, meaning the configuration of the reactant is completely reversed. This stereochemical aspect is crucial in exams and must be remembered. The choice of solvent also affects the reaction mechanism. SN1 reactions perform well in polar protic solvents because they stabilize the carbocation. In contrast, SN2 reactions work better in polar aprotic solvents because they keep the nucleophile free to efficiently perform a nucleophilic attack. These small factors significantly influence the reaction rate and mechanism, making them important for competitive exams. Another crucial factor that students should remember is the effect of the leaving group. Good leaving groups are those that can easily detach from the molecule and remain stable. Halogens such as iodine, bromine, and chlorine are good leaving groups because they are weak bases and can easily break bonds. Iodine is the best leaving group, while fluorine is the worst since its bond with carbon is very strong. The role of the nucleophile also differs in SN1 and SN2 reactions. The SN2 reaction depends on the nucleophile, and a strong nucleophile increases the reaction speed. Negatively charged or soft nucleophiles such as O, CN, and Cha strong nucleophiles that favor SN2 reactions. In contrast, SN1 reactions do not depend on the nucleophile because the rate-determining step is carbocation formation. A key difference between SN1 and SN2 reactions lies in their stereochemistry. While SN1 leads to racemization due to the planar carbocation intermediate, SN2 results in an inversion of configuration because of the backside attack. Another major difference is their dependency on the substrate structure. SN1 favors tertiary alkyl halides due to carbocation stability, whereas SN2 favors primary alkyl halides due to minimal steric hindrance. Furthermore, the type of solvent used in each reaction also plays a crucial role. Polar protic solvents favor SN1, while polar aprotic solvents favor SN2. When considering practical applications, SN1 and SN2 reactions are fundamental in organic synthesis. Many pharmaceuticals and agrochemicals are synthesized using these reaction mechanisms. Understanding these reactions also helps in designing better synthetic strategies in medicinal chemistry and industrial applications. If we compare alkyl and aryl halides do not easily undergo SN1 or SN2 reactions. Why? Because the benzene ring has resonance, which strengthens the CX bond and makes it difficult for the leaving group to detach. Additionally, the sp2 hybridized carbon in the benzene ring is not open to nucleophilic attack, preventing SN2 reactions as well. Due to this, benzyl halides and allyl halides are more reactive since they form resonance-stabilized carbocations, favoring SN1 reactions. Thank you. This was a detailed discussion on the SN1 and SN2 reaction mechanisms of alkyl and aryl halides. This topic is a fundamental concept in organic chemistry and is very important for NEET and JEE exams. If you found this video helpful, don't forget to like, share, and subscribe to receive more such informative videos. See you in the next video with a new topic.